Hello, everyone, and thanks for joining us today. We're very much excited to welcome to this technical walkthrough for Acre. We're fortunate to have Jakub and Nico from Acre site with us. We'll be showcasing the core functionalities of their code base and offer a key insight into their protocol. From the Immunefi site, I'm Daniel, joined by Rudra, our technical expert. Just as a reminder, Acre Boost is now live with a 50K reward pool ready for you to dive into. You can explore more about this Boost program at immunefi.com/explore/boost. For more details. Now, without further delay, Jakub, over to you.
Thank you, Daniel. Yeah, I'm super excited to be here, present you with our code base, and I'm very excited to your findings. Good luck with finding bugs. We are looking forward for your report. Let's start a very high-level overview of what we are building in Acre. I will share my screen, show you some resources that may be helpful with your journey. So let's start with the documentation and the overview. You can get some overview from the docs, so I will just go very high level here, just for you to have some sense of what Acre is. So Acre is it's a liquid staking protocol for Bitcoin. Acre accepts Bitcoin deposits, routes those deposits to different opportunities to earn your rewards on your Bitcoin, such as L2 staking, and all the rewards users will gain will be converted to Bitcoin and returned as Bitcoin. So Bitcoin in, Bitcoin out is the most important part of Acre and simplicity. So anyone can use it, and any Bitcoin native user won't be lost in this space. To get some overview, just refer to the docs, Acre.fi. You will read more about the key concepts, how the stBTC and tBTC underlying protocols work. You will find links to the contracts that we already deployed on testnet and mainnet. So this may be very helpful. I won't go much into details of the docs. Please feel free to read those and learn more. I want to go more into the details of the code and technical aspects of how it's built. To play with the user experience we are exposing, you can visit stake test Acre.fi. This is testnet dApp that you can use. Just connect your Bitcoin wallet and see how it works. And what's underneath of this UI is a backend Solidity contracts. Here's the diagram, the design of the contracts. I will briefly go through this diagram because it will better introduce you to the code base. So as a user, you want to have full Bitcoin experience. So you are using the dApp, and this dApp, through this dApp, we are utilizing tBTC Bridge as integration layer between Bitcoin and Ethereum, because the contracts we deployed are deployed to Ethereum mainnet and Sepolia. So through the tBTC Bridge, we route Bitcoin from the Bitcoin user deposited from Bitcoin chain to Ethereum chain, and then deposit that into Acre. Acre main contract is stBTC contract. stBTC is also a token. It's a liquid state token that is minted to the users that deposited in Acre. stBTC goes back to the user, and Bitcoin converted to tBTC stays in stBTC vault, which is ERC4626 vault, and waits there for allocation. The allocations is what I mentioned, those opportunities to earn rewards on your staked Bitcoin. So through the dispatcher, we route those funds, those stBTC tokens, to different L2s and different staking opportunities. In the initial version, we've got Meso plugged in. We create deposits in Meso portal that will earn points for the users. When user wants to withdraw the funds, they return their stBTC token and they redeem tBTC back to Bitcoin. So we are converting tBTC through the tBTC bridge once again, so we can return Bitcoin to users' Bitcoin wallet. That's a design of the contracts. All the contracts are located in our repository. You should have access to the repository. It's a monorepo. Under Solidity directory, you can find all the contracts. The source code lies in contracts directory. There are the contracts mentioned in the diagram. You can find deploy scripts. Those scripts are used on networks to deploy the contracts. And you can find some artifacts of already deployed contracts, which may be helpful for reproduction of problems, forking, or anything you want to use them for. So for the repo, you will have contracts here under contracts directory. I will go more into details in a second. First, I want to go through all the tabs I have here, just to have some introduction for you all. I mentioned that stBTC token is a liquid stake token based on ERC 4626 standard. This is a common standard for vaults, for tokenized vaults. I encourage you to read more on the resources that are available all over the web. So first and foremost, AIP, which describes the token, the vault, how it works. You can find many details on how the implementation should work. We are basing our implementation on the OpenZeppelin library. They have very decent documentation here on this page, describing how the vault works, mentioning some inflation attacks. This is super helpful resource to understand how the inflation attacks works. They're also describing how the fees work, which I will go more into details when I share the code. Okay, let's dive deeper into the code. I will switch to my VS Code to show you the contracts. So this is the same you've seen in the browser, on GitHub. Here are the contracts. We've got a couple of important contracts here. As I mentioned, stBTC is the most important contract. It's a vault and a token, ERC20 token, in one contract. This implementation is based on the ERC46 from OpenZeppelin. Let's find it here. So that's the base we are using for our vault. We enhanced that with a couple of features I will briefly describe in a second. But you can use it also as a reference in addition to the docs I showed to understand how the vault works and how the calculation in the vaults work. Because in those vaults, you have two concepts. You have shares, which in our case are stBTC tokens, and you've got assets. In our case, those are tBTC tokens. stBTC is non-rebasing token, which means your stBTC amount doesn't change, but the value of those stBTC denominated in tBTC can change once the protocol earns reward for you. For stBTC contract, we added some customizations on top of the ERC 4626 implementation from OpenZeppelin. You can find them here. First thing, we added fees. So we added entry and exit fees for the contract. So users will pay some portion of their deposits and their withdrawals to the protocol. Those fees are included here in this contract. There was some question on Discord if those contracts are also in the scope of the Boost program. Yes, those contracts implemented internally in the repository are in the scope of the program. Only those external dependencies that we are importing are now in the scope. So stBTC contract adds the fees through the ERC 4626 fees abstract contract. Those fees are included in this contract. We also added a couple of more customizations, like minimum deposit limits, which are added to the deposit and mint flows. We expose, as for the standard deposit and mint functions, which are important to understand how to interact with the vault, because those two functions operate on different assumptions. Deposit and withdraw, they operate on assets and are converting assets to the shares upon execution. And mint and redeem operates on shares. So we are requesting minting specific number of shares, and then you open a position in the vault. I won't go through all the functions here. It should be pretty descriptive with the NAT spec and also with the docs on the web to understand the vaults. This stBTC contract accepts TBTC as an asset that we are depositing, and TBTC as an asset that is exiting the vault. But as I mentioned, we want to have Bitcoin experience. So to do that, we introduced two more contracts that will integrate Bitcoin to stBTC through the TBTC bridge. Bitcoin Depositor is first of the contract for the inflow of funds. Bitcoin Depositor initiates deposit on TBTC bridge, and those deposits will be routed to Acre. Here, this contract reflects how the bridging works on TBTC bridge. So first we initialize deposit, then after deposit is finalized on the bridge side and TBTC is minted for this Bitcoin, we finalize the deposit. Finalize deposit function will deposit TBTC into stBTC contract. For the exit flow, we've got a redeemer contract, Bitcoin redeemer contract. This contract routes the funds through TBTC bridge to Bitcoin. So user is requesting a withdrawal, TBTC is removed from stBTC vault, and through Bitcoin redeemer contract, we request bridging of this TBTC to user's Bitcoin account. Those are interactions users are performing, so deposits and withdrawals or redemptions. On the other side, we've got allocations because we want to move the funds from the vault to opportunities that can gain rewards to the users. As I mentioned, first one is Meso portal for Meso staking. We implemented Meso allocator contract that will route deposits from Acre, from the stBTC vault to Meso portal. This contract, users are not interacting with this contract. This contract is managed by a maintainer role. The maintainer calls this contract to allocate the funds periodically, and those funds will be moved from the vault to the portal. This contract implements the iDepositor iDispatcher interface, and this interface is expected by stBTC contract to any dispatching contracts that will route funds from stBTC to staking protocols. Another contract we've got here is a utility contract. It's posable, ownable. It's a mix of posable and ownable. Some of the operations in stBTC contract can be posed by post admin role. It's just for a protection of user funds. If we discover any problems, we'll post deposit and withdrawals, which are most important parts of the vault. And we will enable them later once the threat is no longer in place. Basically, those are the contracts, the code base. We've got some interfaces, which I won't go through here because they're very simple. We've got some contracts that are helpers for tests. They are not in the scope of this audit. Those are just stubs used in tests. For testing, if you want to play with the code and test, you can find tests here in test directory. Those are tests that are based on the local network, local hard hat network. We also have some integration tests, which are based on forks. So you can fork the mainnet and run the contracts, run the tests on actual contracts deployed on mainnet. I believe that's all regarding the intro to the contracts. If you have any questions, I'm open to answer them. We are looking on Discord, so if you need any clarification, just please feel free to ping us.
Great overview, Jacob. I really appreciate. And like regarding NetSpec, I think that's one of the finest or like a thorough explanation of fully utilizing the NetSpec. Like totally makes sense and amazing documentation. I have a couple of questions that I would like to ask and that we have prepared. So as a protocol, you must have been going through previous audits. So what were some of the important bugs that you received during that audit?
Oh yeah, thank you. Great question. So yeah, our code was audited. So from what I remember, one of the most important problems auditors discovered were related to total assets calculation, because in those vaults you need to be very detailed how you calculate the assets and total assets, which are used in the main invariant of the contract to calculate shares and stBTC conversion. So the problem was discovered in meso allocator contract. In meso allocator, when we calculate the total assets, we included the assets that were deposited to meso portal contract. But what auditors paid attention to was that we are not including the balance that is on the contract side. So if there are any rewards transferred, or if someone donates stBTC tokens to the meso allocator contract, we were not including that. This could lead the depositor to mint some more shares than they really should receive, which could mess up the withdrawals for other users and all the shares calculations. So to mitigate this, we just included the balance check of the contract in total assets calculation. What's important here, what I mentioned, are donations. Donations are part of an inflation attack, which is very common in the vault. And this is something that we need to pay attention to. because attackers can use donations to manipulate the conversion rates. This was also brought up by auditors, and a couple of things that we implemented to protect against inflation attacks, to mitigate them. Actually, there were three things we used. So we defined a minimum deposit limit for stBT contract. So no one can deposit less than this particular amount. We hard-coded in the contract. Second thing we did is that we used a virtual share that is built into OpenZeppelin's ERC 4626 library. And the last thing is we created an initial deposit upon the contract deployment, and this initial deposits, this initial deposit will remain in the contract in the system forever. So this is also another mitigation we took.
Amazing explanation. And by the way, if you are curious about knowing more about ERC 4626 or inflation attack, we at Immunefi have posted a couple of articles that might help you in this journey of exploring vaults. Next question, Jakub, would be like, what components in the whole architecture you believe are critical to you? You can order them in like 1 to 3, one being the most critical and third being the less. What do you think is the most critical component of your whole protocol?
I think the stBTC contract is the most important because of how important it is for the vault and token minting and burning. And those vaults invariants and shares calculations are the most crucial parts of this contract. So if I would have to name one, the most important piece, it's stBTC contract and all the conversions.
Got it. And since I think there is a lot of integration between couple of different protocols and layers, right? So is there any tip that you would like to provide on the researcher that they can utilize to understand the architecture much better, like not the docs, but in the code wise, right? So there are lots of integration. So what would be your tip to test them out? Like what would be the ideal way to approach through testing?
I would refer to the tests we implemented, the unit test, the integration test, because we've got examples there. Yeah, the integration with stBTC bridge and the interfaces and the data that are exchanged between those two protocols may get complex. So it would be easiest to just go through the tests and see how the data are assembled there. Also, for integration with stBTC bridge, you can refer to the stBTC bridge documentation and codebase as well.
Got it. And my last question would be, are there any different access control roles throughout the whole code base? And if there are, would you like to tell us more about that?
Yeah, sure. We've got a couple of access control roles in the system. First, the most important role is the owner, because most of the contracts are ownable. The owner of the contract is a governance. This role can manage the parameters of the contracts. I manage other roles that are in the system, manage the dispatcher and allocators. So that's the most important role. There are two more roles. First one is maintainer. Maintainer role is related to mesoallocator contract. This is a very simple role that is responsible for calling the allocate function in the allocator, and the allocate function will route the funds from Acre to Meso portal. This role doesn't have to provide any input parameters to the allocate function, it just calls the function. Another role is pos admin, which is related to the posable contract. It can stop deposit and withdrawals from the stBTC contract.
Got it. And would you mind posting the diagram that you showed on the presentation, the whole architecture of the protocol in our Discord channel, since it was really thorough and easy to understand, Jacob?
Yes, sure. I will share all the resources I showed. Yeah, that's a good point.
Amazing. And by the way, guys, this is your time. So if you have any questions, just feel free to throw it in the chat, and we will pick it up and try to help you in any way possible. So please take your time and ask. Since I do not see any questions, Daniel, can you take over?
Sure. Thank you, Jakub, for this detailed walkthrough, and thank you, Rudra, for guiding us with your additional question and, of course, with clear explanation from the Acre team. It was great. It was great to see everyone attend live, and we appreciate your participation. This session was highly productive. Oh, there is a last-minute question by Devender, whose questions says, can we get a hold of previous audit report? I think is already uploaded in the Boost program. Yeah. Indeed. Yes. So another SR just reply. Thank you so much. So here again, if you have any question, feel free to join our Discord channel with where the Acre team will be happy to respond to any questions or any other technical aspects you might have missed during this presentation, but also that might arise once you start diving into the code. Just as a reminder, a recording of this call will be available by tomorrow at the latest. And for those of you still considering or still thinking whether a bug hunting career is worth considering or not, make sure to check out the Immunefi website bounties, and we will definitely convince you, persuade with those rewards. Once again, thank you all, and happy hunting. Thank you.
Thank you. Good luck. Bye-bye.
Bye-bye, guys. See ya.
Great call. Great presentation.